It's a pleasure to introduce Michael Walker, who comes to us from the University of Guelph in Ontario. And he comes to us as a student of Georgia Mason, and if nothing else, that pedigree alone speaks volumes, those of you who know Georgia. His work is presently focusing on the long-term effects of welfare variables in laboratory animals, and I think there's going to be a number of applications that we'll gain for the zoo world. Michael.
Good morning. So before I start here, I just want to make it clear here that I'm really going to be focusing on negative emotional states and how these influence morbidity, mortality, and ultimately the lifespans in captive animals. And so we know that mortality rates are commonly used in various types of welfare assessments, both in zoos and on farms and in labs. They're used to indicate things like high rates of disease, poor nutrition, behavioral problems such as fighting and serious aggression. They can also reflect accidents or environmental events. So this was actually a picture from the recent flood in Calgary Zoo. And in these cases, mortality is really correlated with poor well-being, as they're both being induced by the causes of the elevated mortality. And so what I mean here is we have these physical stressors and harms, and these lead to increased mortality. This is pretty obvious. And at the same time, these physical stresses and harms are also causing negative emotional states within the animals. And so what we see here is that these two things are correlated with each other. But what we're really interested in and kind of are proposing here is that there actually might be a causal relationship between the two. And so what this would look like here is we have these physical stressors and harms causing these negative emotional states, and then it's then these emotional states that are leading to increased mortality. And kind of our proposed mechanism here is that there are physiological responses to these emotional states. And when these are sustained for long periods of time, they lead to physiological problems and then to increased mortality. And importantly here, we can also include psychological stressors in this model. So these are also important in causing negative emotional states, which can then kind of cascade down this pathway. And so I'm going to take just a quick minute here to look at this physiological response to problem pathway. Because we know that these responses, they're normal and adaptive. They help animals respond to stressors that they may experience in their life. But problems really can occur with sustained activation, and this is also sometimes called allostatic overload. But we know that when blood pressure and heart rate are sustained for long periods of time at high levels, that leads to cardiovascular problems, early senescence, and disrupted autonomic activity. And likewise, high levels of cortisol continuously can lead to insulin resistance, nervous system disorders, and immune disturbances. And just to make things even more complicated, problems can also occur with sustained inactivation, primarily of the HPA system. And chronically low cortisol, which is symptomatic of PTSD, has also been linked to autoimmune diseases. So when these systems aren't working properly, we can see that there are a lot of health effects that can ultimately lead to increased mortality. And so again, like everyone before me, we want to look at humans first. So in order to kind of do this critical anthropomorphism, because the benefit here is that we can get self-report from humans. So we can ask them and look for evidence that emotional states are actually influencing longevity in humans. And it turns out that there's a lot of evidence suggesting that this is true, both for positive and negative states. And so we know that happiness is actually linked to how long people live, and happier people live longer. And this is based on their ratings of things like their optimism, their enjoyment of life, satisfaction with income, satisfaction with their relationships, and factors such as that. And similarly, when we look in certain populations, so among HIV-positive men, positive emotions are then correlated with decreased mortality rates. And really interestingly, chronic depression is correlated with increased viral loads, but AIDS symptoms don't predict depression. So it's not the case that the people with a more progressed stage of AIDS are the most depressed people, but rather the most depressed people are then the ones who go on to have more symptoms and faster disease progression. And looking in other populations such as the elderly, this was a study, kind of a survey done in nursing homes, and they found that elderly people who reported more negative emotions were actually found to be twice as likely to be dead within 4 years when they came back and followed up with those people. And just as a general trend, affective disorders, so things like anxiety and depression, kind of clinically, are found to lead to 1.5 times higher mortality rate than expected based on the general population. And so then this effect seems to be true in a wide variety of circumstances here. So then we want to know, what are the possible mechanisms? And these are three that we've pulled out from the literature. They're by no means necessarily the only mechanisms, but I think there's a lot of good evidence here that these are the things that are maybe causing these people to die. And so just at the most basic level, people that report more negative emotions are actually 6 times more likely to catch the common cold. And obviously this has nothing to do with you don't die from this. But just suggesting that these people actually are immunocompromised. And in a more serious case, severe stressors experienced by HIV-positive men. So these are really serious negative life events. So death of a child or a spouse or another family member, loss of a job, things like that. People experiencing any of these severe stressors are then found to have a disease progression rate about 2 to 4 times greater than anyone who's not experienced any of these stressors. Similarly, when we look at cancer, there's a positive correlation between the number of severe stressors, so those same kind of stressors experienced by women, and then their subsequent risk of developing breast cancer. And people who with a more negative reaction to a cancer diagnosis are known to have faster disease progression and then poorer responses to the treatment. And finally, when we look at our third kind of mechanism here, cardiovascular disease, there's this interesting study of medical professionals. So people who report feeling hopeless were then later screened for cardiovascular disease, and those people who are more hopeless have increased baseline levels of atherosclerosis, and then when they follow up 4 years later, those people actually had faster progression of the disease as well. And in this kind of neat meta-analysis, they found that psychosocial stressors were found to account for up to 30% of the risk of having a heart attack, and only lipid status and smoking were more powerfully predictive, whereas things that we tend to think of as being really important, like diabetes, poor diet, and sedentary lifestyle, were actually less powerfully predictive than experiencing psychosocial stressors. And I just want to note here quickly that in all these studies, they do a pretty good job of controlling for potential confounds. So they're always controlling for age and sex of the participants, for diet and exercise, for smoking and alcohol consumption. So there really are, seem to be effects of these emotional states on these outcomes. And then, so obviously we want to know, do we see similar effects in animals? And as it turns out, yes. So I just want to run you through a few quick examples. Hopefully I have enough time to get through them all. Looking at these, so we're going to look for essentially exact parallels within animals. And so in one example here, we have rhesus monkeys. They're infected with SIV, and then they're put in either stable or unstable social groups. So the unstable social groups always have rotating members, never the same composition, whereas the stable groups are always the same individual animals. And so here we can see the blocks here, they're just different time periods, but the clear bars represent the unstable groups, and the shaded bars here are the stable groups. So you can see that the unstable groups are doing a lot more threatening behavior to each other. And then conversely, when we look at these more positive interactions of grooming, we can see here that the stable groups are the ones then doing more of this behavior. And then when they follow up, a year later, a year and a half later, they actually found that the individuals in the stable groups live significantly longer than those in the unstable groups. The difference here was about 160 days following inoculation with the disease. And similarly, there's an example here from semi-wild rabbits where they look at the dominance hierarchy. And so they found that the dominant rabbits were receiving the lowest levels of aggression. So here we have the rank of the individuals within the group. So 1 is the top rank. So they're the ones doing the offensive behavior to the others, beating up on the other rabbits. And importantly also, they're scoring sociopositive behaviors from the females. So they're getting all the female attention. And when we look at their physiology here, we can see, again, very similar effects. So they have the lowest baseline levels of corticosterone. They have the lowest baseline heart rates, both consistent with kind of being the least stress group. And when we look at their lifespan, these dominant animals are living significantly longer. So on average, they're about 30% longer, which is the difference of an entire breeding season for these animals. So quite a significant difference. And we can also consider non-social stressors. So this is an example. These come from zoo rhinos. And their scores for fear were found to be positively correlated with the percent of the enclosure available for public viewing across institutions. And then interestingly, when we look back, their past mortality rates were also found to correlate with the percent of the enclosure available for public viewing, suggesting that there may be a link here between their fear and their mortality rates. This is one of my favorite examples, but positive affect can be protective in animals as well. So they had zookeepers fill out this kind of questionnaire about their orangutans, including some kind of interesting things like how happy the zookeeper would be if they were the orangutan, as a way to kind of subjectively judge their happiness. And so they then followed up over a 7-year period in their scores for subjective well-being here. So this is kind of subjective well-being -1 standard deviation. So this is kind of the worst subjective well-being, and this is the best down here. And then we have their risk of dying kind of as they age. And so obviously, as you get older, your risk of dying increases. But in the group with the kind of the worst well-being here, theirs is increasing at a much faster rate. And the difference between this group and this group here is about 11 years. So essentially, this means that kind of a 29-year-old unhappy orangutan has the same risk of dying as a 40-year-old happy orangutan, which is, again, a very large difference. And then there's some cases that are not so clear-cut. So this is an issue where we're not really sure what's going on, but definitely these kind of negative emotions can play a part. So when we consider transport of animals, this involves not only kind of capture and the stress of moving the animals, but also, breaking their social bonds, forcing them into new social situations. And we can see that the number of inter-zoo transfers predicts mortality rates in captive elephants, particularly in Asian elephants. And similarly, we see this really high period of post-capture mortality in marine mammals that lasts for about 60 days. And obviously, there are other things going on here, such as being introduced to new diets, potentially being introduced to new diseases. But it's certainly possible that these kind of negative emotions are playing a role in these examples as well. And again, when we look for these same mechanisms, again, I'm going to cover the same 3, but there's a lot of evidence that I don't have time to go into here, so just a couple examples. But essentially, we see the exact same thing in animals that we see in humans. So according to various measures of immunity, the immune systems of socially housed macaques function at an enhanced level, so natural killer cell activity and lymphocyte proliferation are much better in group-housed macaques rather than isolates. And when we look at cancer, the same thing. In rodents, there's a lot of evidence from rodents developing cancers, but the stressors such as being handled and restrained a lot or being introduced into a dominant animal's cage repeatedly has been known to increase the pathogenesis of various cancers. And neophobic rats, so these are rats that are more afraid of novelty, they react more to new situations. These animals have an increased risk of developing tumors and as a result decreased longevity. And in a review of cardiovascular disease among social animals, social isolation, subordination, and receiving hostility have also been found to predict much higher levels of atherosclerosis in these animals. And so obviously, this isn't a perfect indicator of emotional state. There are some issues with it. We know that high mortality rates don't always reflect past poor emotional states. So there are other factors that we need to consider. So gender of the animal is obviously important. Body size is important, so larger animals tend to live shorter lives, and genetics as well. So inbred and purebred animals, again, tend to live shorter lives just because of their genetics. And similarly, poor emotional states will often fail to be detectable via mortality rates. So small changes in emotional states are really unlikely to translate into mortality effects. So animals aren't that fragile. And also importantly, harmful effects can be delayed in their manifestation. So sometimes young animals will experience these stressors and we won't see any results until they reach middle or even beginning of old age. And finally, calorie restriction is a great way if you want to make your animals live longer, but we know that this means that they're probably chronically hungry for their whole life, so that's not really a solution either. So what can we do with this? We know that the evidence suggests that negative emotional states are related to mortality via causal roots, and that decreases in lifespan can occur without any kind of physical harm. And so obviously we can't use this information once we've collected it for the animals because they're dead. So what can we do with it? We want to use this information to identify risk factors by making comparisons between institutions or individual animals. We can look at things like climate, enclosure design, management practices, transfers. I mean, the list could be endless here. And the best part is that it's really easy to collect this data. We just have to be really fastidious in record keeping. Again, we can control for a lot of these confounds, like similar in the human examples, statistically. So we can really begin to parse out what are the important factors in causing these animals to live shorter lives. And that's it. Thanks.
Thank you, Michael. Thank you, Michael. Questions, please? Yes, Ron Kagan.
Michael, that was fascinating to see all of this. In the zoo world historically, we have considered success to be correlated with reproduction and with longevity. And indeed, the statistics show that generally animals in zoos live longer than they do in the wild. I'm not sure that takes into account the issue of predation in the wild, which might very well account for that. But I guess my question would be, if, again, at the risk of being anthropomorphic, but since you've used a lot of human comparisons here, has anyone done a study, for instance, on longevity of prison populations? I mean, can you show that a human that is in a captive environment is going to live just as long as someone who's not? And would that challenge this fundamental premise?
I'm not aware of a lot of evidence. I believe I've read some looking at actually Holocaust survivors and kind of going through that event and then coming out the other side. And then that group of people actually tend to live shorter lives kind of than you would expect based on the general population as well. But I don't know if I've looked at anyone specifically in prisons.
Other questions?
Hello, Scott Terrell from Disney. I'm a pathologist by training. Mortality is a pretty extreme endpoint for these studies. I wonder if there's an application for some of this discussion, not using mortality as your final evaluator, but morbidity. We've tried to have conversations where it's not necessarily the quantity of life that's important, but the quality of life. So using these emotional or physiological states to evaluate the quality of life while the animals are with us, not just whether or not they die at the end point.
Yeah, definitely. So I guess in terms of that, we could equally collect data on morbidity rates within populations and use that as well to kind of look back at these risk factors, because I think it's really clear. So not only in kind of these three disease mechanisms that I've kind of talked about today, but there's a lot of different physiological things that can happen based on these negative emotional states and this kind of cascade of responses. And we can look at, yeah, I think you're right. Like we could easily collect data on morbidity rates just as easily and use those to make predictions as well.
Well, maybe I have one. I have a question. What about, I know it'll be speculative on your part, but what about remedial plans? If one had a situation where you knew that the animal were under stress and that we're going to be a negative effect on a long-term lifespan, what are we to do?
Yeah, I mean, I guess the best thing that we can do is kind of take care of them the best that we can now. And that really I'm kind of suggesting that we use kind of the evidence moving forward so that we can look back and say, these are the kind of things that worked, these are the kind of things that led to good health, low morbidity rates, low mortality rates, and long lifespans, and then kind of build on those in the future as kind of the zoos evolve moving on. But I guess now it's no different than any other welfare indicator, welfare issue. They just need to be addressed as best as possible now.
Thank you. Gordon.
A quick comment. This raised the issue of if you transfer animals both within as well as between zoos,
Yeah.
one of the processes that's being used is training the animals so that they are used to going into enclosures. So you can, rather than stress them, they're doing this with crocodilians now with great success. So one way would be to try to reduce the stress of, for instance, transfers, which often are important or inevitable, or you have to transfer animals both within and between zoos. And so some of these behavioral training procedures, I think, that psychologists have developed, I think are really essential to be implemented in zoos more consistently.
Yeah, definitely. And so what I would suggest is then we can actually look, we can collect data on those animals that have been, either trained or not trained as for transfer, and then look at the outcomes based on those variables as well. So we can actually use that to gain evidence, to make these kind of evidence-based recommendations in the future.